Hello students, in this video we will study about metallic and electrolytic conductance. So before we start the topic, we need to know what are electrolytes. Electrolytes are the substances that dissociate into ions in aqueous solution. For example, if I take KCl, it will dissociate into K plus and Cl minus. So this is an electrolyte. Why this is an electrolyte? Because it is dissociating into its constituting ions. These are K plus and Cl minus. Similarly, if I take NaCl, it also dissociates to Na plus and Cl minus. So NaCl is also dissociating into its constituting ions. So therefore, it is also an electrolyte. Okay. There are generally two types of electrolytes. One is strong electrolyte and another is weak electrolyte. Okay. The strong electrolytes, they dissociate completely into ions. They dissociate completely into ions. But the weak electrolytes, they do not dissociate completely into ions. इसका मतलब क्या है? फॉर एग्जाम्पल, अगर हम लोग NaCl लेते हैं तो ये डिसोशिएट होगा Na प्लस एंड Cl माइनस में. अगर मान लो मैंने 100 मॉलिक्यूल ऑफ NaCl लिया है तो ये 100 मॉलिक्यूल Na प्लस फॉर्म होगा और 100 मॉलिक्यूल Cl माइनस फॉर्म होगा. बट इफ आई टेक CH3COOH, this is the acetic acid, which is a weak electrolyte. So it will dissociate into ions, but it will not dissociate completely. That means, what are the ions? This is CH2COO, this is acetate ion and hydrogen ion. So for example, if I take 100 molecules of acetic acid, so it will not dissociate into ions completely. Let's say 20 molecules of acetic acid is being dissociated. So after dissociation of 20 acetic acid, 20 CH3COO minus will form and 20 H plus will form. And rest 80 molecules of CH3COOH will remain undissociated. Okay. So I am taking just an example. Okay. That means 20 molecules will dissociate and 80 molecules will remain undissociated. Okay, it may change. Okay. So weak electrolyte means what? The electrolyte which do not dissociate completely into ions. Okay. Next, what are the factors upon which the conductivity of an electrolytic solution depends? किस किस फैक्टर के ऊपर इलेक्ट्रोलाइटिक सॉल्यूशन का जो कंडक्टिविटी है वो डिपेंड करेगा? नंबर वन, nature of the electrolyte. Number one is nature of the electrolyte. Okay, as we know that there are two types of electrolyte. One is strong and another is weak. So strong electrolyte dissociates completely into ions. Okay, and weak electrolyte will partially dissociate into ions. So in case of strong electrolyte, the more number of ion will produce, but in case of weak electrolyte, less number of ion will produce. So we know more the number of ion, more is the electrical conductivity. So therefore, in case of strong electrolyte, the conductivity is high, and in case of weak electrolyte, the conductivity is low. Next is nature of solvent. Next is what? Next is nature of solvent. Electrolytes ionize more in polar solvent. Okay, electrolyte ionize more in polar solvent. For example, H2. H2 is a polar solvent. Therefore, the electrolytic conductance will be more in water with respect to any other non-polar solvent. Okay, next is size of the ion produced and their solvation. Okay, if the ions are strongly solvated, their effective size will increase and hence the conductance will decrease. Okay, that means more the solvation, less is the conductance. Okay, next is concentration of electrolytic solution. Next is what? Next is concentration of electrolytic solution. So we know more the concentration, more is the conductance. Okay, more is the concentration means what? More is the number of ions present per unit volume. Therefore, more the ion, more it can conduct electricity. Therefore, it is directly proportional to the conductance. Next is what? Next is temperature. The conductivity of an electrolytic solution depends upon the temperature. How it is dependent upon the temperature? It increases with increasing temperature. Why? Because more the temperature, more is the mobility of the ion. Okay, so more is the mobility, more is the conductance. So temperature is directly proportional to conductance. Okay, so these are the factors upon which the conductivity of electrolytic solution depends. Next, we will understand the difference between metallic and electrolytic conductance. For example, it is a metal. This is an electrolytic cell. Okay, this is an electrolytic cell. So see, in the electrolytic cell, there is a battery. The positive terminal of the battery is connected to this electrode. Therefore, it is positive in charge. Now, negative terminal of the battery is connected to this electrode. Therefore, this is negatively charged. So what will happen in the electrolytic cell? There is an electrolytic solution present between the two electrodes. Okay, so this electrode is positively charged and this electrode is what? Negatively charged. Now say an electrolyte NaCl is dissolved in the solution. Okay, this NaCl will dissociate into Na plus and Cl minus ions. So since the electrode is connected to the positive terminal of the battery, this electrode is positively charged and this electrode is what? Negatively charged. So now as we switch on the circuit, the positive charged electrode will attract the negatively charged particle, that is anion, and on the other hand the negatively charged electrode will attract the positively charged cation, and this is how the electricity conducts in the electrolytic cell. So what is the difference between metallic and electrolytic conductance? Okay, So as I have told earlier, this is a metal, and this is what? This is an electrolytic cell. Okay, this is an electrolytic cell. So what is the first point? Electric current flows by the movement of electrons. So in the metals, we know metal contains a sea of electrons. So many electrons are there in the metal. So electricity flows by the movement of electrons in the metals. But on the other hand, electricity flows due to the movement of ions. Where? In the electrolytic cell. So, in the electrolytic cell, the conductance arises due to the movement of ions. Next is what? In the metallic conductor, no chemical change takes place. Okay, only the electron flows through the conductor, but there is no chemical change inside the conductor. But in the electrolytic cell, there will be oxidation and reduction reaction in the respective electrodes. So, the reaction occurs in the electrolytic cell. Therefore, the chemical change occurs in the electrolytic cell. Next is, it does not involve the transfer of any matter. Okay, in the metallic conduction, it does not involve the transfer of any matter. Okay, but in the electrolytic conduction, it involves the transfer of matter as ions. Okay, now in the metallic conductor, the resistance increases with increase of temperature. That means resistance is directly proportional to what? Temperature. But in case of electrolytic conductance, the resistance is inversely proportional to temperature. Means more the temperature, less will be the resistance. That means when we will increase the temperature, the ions can move freely through the electrolytic solution. So therefore the conductivity will be more. Okay. Next, let us consider a metallic conductor of length L and A is the area of cross section. So we know that is directly proportional to the length of the conductor and inversely proportional to the area of cross section. So we know that R will be proportional to L by A. So using proportionality constant, R is equal to rho L by A. Okay, this much we know from class 10. So similarly, when you calculate the resistance of the electrolytic conductor, we take the distance L as the distance between the two electrodes and A is the area of the conductor. So similarly, in this case also, so resistance is directly proportional to length between the two electrodes and it is also inversely proportional to the area of the electrode. So similarly, I can write R is proportional to L by A. Now R is equal to rho L by A. Now what is rho? Rho is proportionality constant. This is called the resistivity of the conductivity cell. Now as I have written R equal to rho L by A, I can write rho equal to R A by L. Now inverse of rho that is will be equal to L by R into A. Okay, so inverse of rho, that is resistivity, will be what? Will be conductivity. Will be conductivity denoted by what? Denoted by kappa. This is called KAPPA. Okay. So what I can write? I can write 1 by R into L by A. Okay. and kappa is nothing but it is the conductivity, or it can be also said as specific conductance, conductivity or specific conductance. Okay, so this is the formula how we will calculate the conductivity of the electrolytic cell. I can modify the formula also. What I can write? I can write kappa equal to C into G star. Okay, what is C? C is what? C is the conductance, and C is what? C is inverse of resistance, that is conductance. And G star is what? G star is nothing but it is cell constant. Okay, so kappa equal to C into G star. So now tell me, what is the unit of kappa? What is the unit of kappa? That is specific conductance. Okay, so from the formula C, what is the formula? It is 1 by R into L by A. So what is the resistance? What is the unit of resistance? This is ohm. And what is the unit of length? This is centimeter, and area will be equal to centimeter square. So the unit is ohm inverse centimeter inverse. Okay, and this ohm inverse can also be written as mho, mho, mho centimeter inverse. Okay, or I can write Siemen, SIEMEN, Siemen centimeter inverse, or S centimeter inverse. Okay, so this is the unit of kappa, that is conductivity or specific conductance. Now when the concentration of the electrolytes in the conductivity cell, okay, electrolytes in the conductivity cell is 1 molar, then in this case the conductivity is said to be molar conductivity. Okay, so molar conductivity is defined as the conducting power of all the ions produced by dissolving 1 mole of an electrolyte in the solution. मतलब 1 मोल इलेक्ट्रोलाइट डालने के बाद जितना कंडक्टिविटी शो होगा, इसको हम लोग मोलर कंडक्टिविटी बोलेंगे. And the molar conductivity is dependent on the nature of electrolyte. Okay, मतलब अगर NaCl लेंगे तो मोलर कंडक्टिविटी एक होगा, KCl लेंगे तो मोलर कंडक्टिविटी दूसरा होगा. That means जो इलेक्ट्रोलाइट है इसके ऊपर मोलर कंडक्टिविटी डिपेंड करेगा. So how we find the molar conductivity? Lambda m equal to 1000 kappa by molarity. Okay, lambda m equal to 1000 kappa by molarity. So this is the formula how we calculate the molar conductivity of the electrolytic cell. Now what is the unit of lambda m? What is the unit of lambda m? Okay, so 1000 kappa by C. From the formula, what is the unit of kappa? This is Siemen centimeter inverse. And what is the unit of molarity? This is what? Mole per liter. Okay, so I can write Siemen centimeter inverse divided by mole, and in place of liter I can write centimeter cube. So therefore it will be Siemen centimeter square mole inverse. Okay, so this is the unit of molar conductivity. Similarly, when the concentration of the conductivity cell is 1 normal, okay, 1 normal, that is the conductivity is said as equivalent conductivity, that is lambda equal to 1000 kappa by normality. Okay, 1000 kappa by normality. Now we will solve some numericals. The resistance of a conductivity cell containing 0.001 mole KCl solution at 298 Kelvin is 1500 ohm. So what is given? Given is resistance. Resistance is what? 1500 ohm. Okay. And what is the concentration? What is the concentration or molarity I can say? What is the molarity? That is 0.001 molar. Okay. What is the cell constant? What is the cell constant? Means I need to find G star. Okay. Of the, if the conductivity of 0.001 molar KCl solution at 298 Kelvin is this. So conductivity means what? Kappa is given. So kappa is 0.046 into 10 to the power minus 3 Siemens centimeter inverse. Okay. So we know that kappa equal to 1 by R L by A, or I can write kappa equal to 1 by R into G star, and again I can write G star equal to kappa into R. So therefore, what is G star? That is, what is cell constant? What is the value of kappa? 0.046 into 10 to the power minus 3 into, what is the resistance? This is 1500 ohm. So the result will be 0.219 centimeter inverse. How we have written this unit as centimeter inverse? So G star means what? G star means what? Cell constant. Okay, this is L by A. What is the unit of length? Centimeter. What is the unit of area? Centimeter square. This is centimeter inverse. So this is the answer. Next, the conductivity of 0.20 molar KCl solution at 298 Kelvin is 0. This. Okay. Calculate its molar conductivity. What is given? Conductivity means what? This is kappa. Kappa is what? 0.0248 Siemens centimeter inverse. And what is the molarity? What is the molarity? 0.20 mole. Okay, mole per liter. So what I need to find? I need to find lambda m. I need to find molar conductivity. So we know that lambda m equal to 1000 kappa by C. C means what? Concentration in molarity. So what I can write? I can write 1000 into 0.0248, okay, divided by 0.20. So the result will be 124.0 Siemens centimeter square mole inverse. Okay, remember the unit of the molar conductivity, Siemens centimeter square mole inverse. Next is, a conductivity cell is filled with 0.01 molar KCl solution. So molarity is what again? Molarity is 0.01 molar. The resistance is what? 747 ohm. And temperature is what? Temperature is 25 degrees Celsius. Now, when the same cell was filled with an aqueous solution of 0.05 molar calcium chloride solution, the resistance was 876 ohm. Okay, this is the first case. So in the second case, the same cell, okay, in the second case, the same cell, okay, is filled with 0.05 molar calcium chloride solution. Okay, when they have told that the cell is same, that means G star will be same in both the case. G star will be same in both the case. That means the cell constant will be same in both the case. So the molarity in the second case is equal to 0.05 mole per liter. Now the resistance has changed into 876 ohm. So what do we need to find? We need to find the conductivity of the solution, that is kappa. Okay, and in the second case we need to find the molar conductivity. Okay, we need to find kappa as well as lambda m in the second case. So as they have mentioned, the cell is same. Okay, so from the first case we need to calculate the G star. So we know that G star is equal to kappa into R. So what is kappa? What is kappa for the first case? It is given conductivity of 0.01 molar KCl solution is this much. Okay, 0.14144 Siemens centimeter inverse into what is the resistance? The resistance is how much? 747 ohm. So G star will be equal to 1.29 centimeter inverse. So as we know, the cell constant will be same, so we will use the cell constant in the second case. Okay, so in the second case we need to find what? We need to find the conductivity, that is kappa. So kappa equal to, we know that it is 1 by R into G star. Okay, so 1 by, what is the resistance? Resistance is 876 ohm. And what is the value of G star? This is 1.29 centimeter inverse. So the answer will be 0.248 into 10 to the power minus 2 Siemens centimeter inverse. Again, what we need to find? We need to find lambda m, that is molar conductivity, and the formula is what? 1000 kappa by molarity. Okay, so 1000, what is the value of kappa? Kappa is 0.48 into 10 to the power minus 2. And what is the molarity? This is 0.05 mole per liter. So the result will be 124 Siemens centimeter square mole inverse. You just calculate and you will get the same result. Okay, that's all about the today's lecture.